Lists are an essential Python data structure. And so an example of a list would be, let's create a list called dogs. So we're going to create the dog names. We have Roger, we have Sid, and this allows you to group together multiple values and reference them all with a common name. So we have a list of dogs, and this is just 2 strings. So the list always going to have the opening and closing brackets, and each item in the list is going to be separated with a comma. And a list can hold different types of values. So these are all strings, but we can have a string, an integer, a string, a boolean, and you can mix different types of data types in a single list. And then you can check if an item is contained in a list with the in operator. So we talked about the in operator earlier, but let me show you how that works. So we're going to print, here's where we can use the in operator. We're going to check if Roger is in dogs. So let's see. So run that, true. But now let's check if Bo is in dogs. Well, false, because it's checking. So this is how you can check if an item is in a list. You can also define a list as an empty string. So I could actually just remove all this, and now we just have an empty list. And this is obviously still going to be false because there's nothing in that list. But let's go back to when we had some items in the list. And you can reference items in a list by their indexes, starting with 0. So I'm going to do dogs, and then I can use these brackets. So, and now I'm going to put so this is where we're going to reference the thing, an item from the list, and I'm going to type in 0, which will be this item right here, Roger. Or I could put 2, and it's going to do 0, 1, 2, and now we're going to have Sid. And the same. And you can use this same notation to update an item in a list. So I'm going to add another line of code here and put dogs2 is going to equal Bo. And now I'm just going to print the entire list here. And now, instead of being Roger 1 Sid true, it's Roger 1 Bo true, because we've updated the item at index 2 to be Bo instead of Sid. Now you can also use the index method. So instead of, like, if I want to find the first item on the list, I could do it like this. So you can also use a negative number here, just how we saw in the string. So -2 is going to start with 1, 2. Actually, let's do -1. So it should return true here. Okay, true. So it starts with this one if you put a negative number. You can also extract part of the list. Now, this is very similar to what we showed using with the string. Let me just add another item here. Now, I am going to use the colon to do part of a list. So I'm going to do 2, 4, and so this is a slice. So it's going to start at the second, or 0, 1, 2, which is now Bo, because we changed it to Bo, and it's going to go through 4. It's going to go through 4, but not including 4. So it's going to be 2, 3, and then not 4, so it's just Sid and true, or Bo and true, because we updated 2 to Bo. And you can also just leave this blank, so it's going to go through the end of the list, or if you leave the first number blank, it's going to start at the beginning of the list, and we can go through, for instance, index 3. And so that's a way to slice the list. You can also use the length function. So let's find out how many items are in the list. I'll use the length. The length of dogs is 6. There's 6 items in the list. We can also add items to the list by using the append method. So I'm going to do dogs.append, and then I can add an item. So I can say something like Judah, and now if we see the length, there's now going to be 7, and if we just print the full list, then we can see all the items, including the one that was just added. We can also use the extend method. The extend is another way to add an item to a list. So if I do, instead of dogs.append, I can do dogs.extend, and then I'm going to pass in, instead of just passing in the string, I'm going to pass in the item as a list. So and it's going to add it just the same, but now I can actually combine two lists together. So I'm going to put a 5. So if I do this, we can see now we are taking this list and extending it by adding this list on the end. This is a 2-item list, and we have that 6-item list, and now we have the 8-item list. You can also use the plus equals operator. So to use the plus equals operator, I'm going to do dogs. It's the same. It's going to do the same thing as extend. So plus equals, and then we have this list. Take this parentheses off here, and it should look exactly the same. See, it's showing up the same thing up here. So the plus equals is going to be the same thing as extend, where it takes the list that already exists and adds this other list to the end. And when you're using the extend or the plus equals, you don't want to forget the square brackets here. So if you forget the square brackets, and let's say I'm just going to add this item to the list, it's now actually going to put each letter individually here. So you can kind of see it better if I move over here. So you want to make sure you put the brackets. And another thing you can do is remove. You can remove an item using the remove method. So I'm going to do dogs.remove sid. Okay, now I'm going to play it here, and it's saying, what did I do wrong here? Oh, obviously, I'm removing sid, but we've already changed the element of sid to Bo, so let's remove Quincy, and let's try that. Okay, so now there's no Quincy. So another common thing to do, another common list method is pop. So if I do dogs.pop, it's going to remove and return a single item. So first I'm going to do print dogs.pop, and then I'm going to print dog. So first it's going to return 5. That was the last item that we added onto the list. And now when I print the list, that item's onto the list. So pop is going to remove the last item from the list, and it's going to return the last item. It's going to return and remove the last item from the list, and then it's not on the list anymore. Now let's make this, let's simplify this. Just go back to the initial list, and I'm going to change this to items. Now I'm going to show you how to add an item in the middle of a list at a specific index. You can use the insert method. So I'm going to do items.insert. I'm going to put the index, which is we're going to insert at the index number 2, and the item is going to be test. And then I'm just going to print that, print items, and then I'll run that, and then we can see at index number 2, we now see the item test. Now to add multiple items at a specific index, you need to use slices. So let me show you how you would do that. So we're going to do a slice, and then I'm going to set that equal to test1, test2. We print that. So now you can see we have test1 and test2 right here, kind of right behind this search thing here. And we've inserted multiple items into the list, starting at index 1. Now you can also sort a list. So if I do, here we go, items.sort, it will sort the list. But you have to make sure, okay, we have an error. It's not supported between, we have a combination of ints and strings. So let's make it so it's all strings in the list. and then it should be able to sort it. Okay, now the strings are in alphabetical order, and if we were using integers or floats, then they would just be in numerical order. Now, one thing that's interesting about that, if I change this to bow, you'll see now we have this at the beginning and this at the end. The sort method orders uppercase letters first and then lowercase letters. So to fix that, actually to make it make more sense, we're going to change that to Bob. And to fix that, within the sort, I'm gonna put key equals str dot lower. And now it's going to sort these correctly how you would imagine, not caring about uppercase or lowercase letters. Sorting modifies the original list content. So to avoid that, you can copy the list content using, let me show you. If we do items copy equals items, and then we make a slice with nothing at the beginning and nothing at the end, so it's going to start at the beginning of the list to the end of the list. And now we can have a copy, and I can print items copy. So if I print that, so now we see we have the sorted list that we ran the sort on, but we also still have the original list. So with all the words in the original order. And there is also a way to sort a list without returning a new list. There's also a way to sort a list without modifying the original list. So instead of copying a list, what I'm going to do is instead of doing items.sort, we're going to use a global function called sorted. So in the sorted function, we are going to pass in two parameters. So first is the list, items, and then the second is how we're sorting it. So this just makes sure that the case of the letters don't matter. And then I'm just going to print that. Now if I run this, you can see we printed the sorted list, and now we're printing the list, and it's no longer sorted because this created a new list without modifying the original list. Okay, now let's learn about another data structure called tuples. So this time I'm going to put tuples. So we're using a comment here. So tuples are another fundamental Python data structure. They allow you to create immutable groups of objects. This means that once a tuple is created, it cannot be modified. So we already saw that we could modify lists, but a tuple, you can't even add or remove items. They're created in a way similar to lists, but using parentheses instead of square brackets. So for instance, I'm going to do names equals, instead of using square brackets, we're going to do parentheses, Roger and Sid. Okay, so a tuple is ordered like a list. So you can get its values by referencing an index. So I could say, for instance, names, and if I do the bracket, I could put a 0 here to return Roger. And then you can also use the index method. For instance, names dot index, and then I can pass in something like Roger, and then this is going to return 0 because it's going to get the index number of that. So as with strings and lists, using a negative index will start searching from the end. So I could do -1 to start, not -0, -1 to start searching from the end here. And you can count the items in a tuple with the length function. So I could do, if I do length and then do names, if I printed that, it would just print 2 because there are 2 items in that tuple. Then you can also check if an item is contained in a tuple with the in operator, very similar to a list. So I can do, this time I will print it. I'll do print Roger in names. So if I print that and run it, we'll see true because Roger is in the names. And then you can extract part of a tuple using slices, just like we could do with strings and lists. So I could do names, and then I could do 0 starting at the 0, 2. So that's just going to start at the 0 index and be done at the index 2. And then you can use you can get a sorted version of the tuple using the sorted global function. So remember, when we were looking at lists, when we used the sorted function, it created a new list. So when we're using the sorted function for tuples, it creates a new tuple. So I can say sorted names, and this would put them in alphabetical order. They already are in alphabetical order, but say there was one more word in this list, and then I can print this to print the sorted version, but it's not actually going to modify the list because you cannot modify a tuple. And then you can create a new tuple from existing tuples using the plus operator. So I could say something like new tuple equals names, and then I could use the plus operator, and then I would just say Tina and Quincy. I could add so these will combine 2 tuples into a new tuple, but you can never, like I said, you can't actually modify the original tuple. Now let's learn about dictionaries. Dictionaries are another very important Python data structure. While lists allow you to create collections of values, dictionaries allow you to create key value pairs. We already discussed dictionaries a little bit, but now we're going to discuss even more about dictionaries. So let me give you an example of a dictionary with just one key value pair. So dog equals, and then we're going to use the curly braces to create the dictionary, and I'll put name, and then I will put Roger. And just like any type of strings, we could make these single quotes or they could be double quotes. And the spaces here are not very important, but it's common to put spaces in between these things for better readability. And the key can be any immutable value. So this is a key, and this is the value, and the key can be any immutable value, such as a string, a number, or a tuple. The value can be anything you want. So a dictionary can contain multiple key value pairs. So like for instance, we got the name, we can have age, and that's going to be 8. And you can access individual key values using a notation like this. So I can say dog, so I'm using the bracket notation. I can do name. So if I print this, it's just going to print Roger. And then again, I can use the single quotes too if I want. And it still prints Roger. And then you can use the same notation to change the value stored at a specific index. So let's say I want to change the name. So if I do dog, and I'm going to say that the name is now going to equal Sid. Now I'm just going to print the whole thing, and we can see the name is now Sid instead of Roger. So another way to get a specific element is to use the get method. So if I do a dog.get, and then I do name, so I'm going to try to get the name here, it's going to return Roger. So one good thing about this is that you can add a default value. Like, let's say I'm searching for color, and it's saying none. It's giving it none because there is no color. But what if I want a default value? So I'm going to put comma, and then I'll put brown. So now if it cannot find the color in the dictionary, it's going to return brown. But if it can find the color, like let's say color and this is a green dog. Okay, we'll return green. So with the bracket notation that I was showing you earlier, you cannot have a default value. So that's one good thing about the get method. Now, you can also use the pop method to retrieve the value of a key and delete the item from the dictionary. Well, we also showed the pop method for lists. So, for instance, I can say get.pop, and then I will pass in name. And then right after that, I'm just going to print dog, the whole dictionary. So first we're going to get Roger, and then when I print the dictionary here, it's not going to show Roger anymore because we deleted it. Pop will return the item and delete the item. Now you can also use a method called pop item. The pop item method, well, let me show you that one. Pop item, it's going to retrieve and remove the last key value pair inserted into the dictionary. So in this case, it should be color. So if I run this, it's going to return color green. And now when I print out the dictionary, it's not going to show color green because that was already removed. It removed the last item. You can also check if a key is contained in a dictionary by using the in operator. So we're going to try to find out if color is in dog. If there's a key called color in dog, we run that and it says true. Another thing we can do is get a list with the keys in the dictionary using the keys method. So if I do dog.keys, and then we'll run that, it's going to show the keys. So the keys are name, age, and color. We can see that it's inside this thing called dict keys, but we can also pass this into list, so we return just the list part. So now we can see it's just an actual list, name, age, and color. And then we can do the same thing with values. So instead of dog.keys, let's do print dog.values. We'll print that, and you can see we have Roger 8 green. We can pass it into a list to return just the list here, Roger 8 green. And then finally, if we just do items, it's going to return all the items in the list, or all the items in the dictionary, and convert it into a list. So you can see this is the first item in the list, this is the second item, and then we have the third item here. So we can see each item of the list, each item of the dictionary is now in a list. And then, like a lot of the other things, we can use the length function, and I'll just put dog, and we can see that there are 3 items in dog. Now you can also add a new key value pair to the dictionary. So let's say I want to do dog food, or it doesn't even have to be a single word. I could put favorite food, and I'm going to say meat. And now we're going to print that. Let's see, what did we, this was supposed to, I did that a little wrong. There we go, this is actually how you do it. You use the bracket notation equals, and then put what it equals there. Okay, now you can see that we now have a new item on the list, favorite food, meat. And then you can also delete an item from a list, or delete a key value pair. So I'm going to, del means delete, dog, there we go. And this time I'm going to delete color. And I'm just going to use single quotes instead of double quotes to show you that it doesn't really matter the type of quote. And now you can see we don't know what color this dog is. It's no longer a green dog. And then you can also copy a dictionary. So if you want to make 2 copies of a dictionary, you can do it like this. Dog copy, that's the name of the new dictionary. I'll do dog.copy, and that would be the new copied version of the dictionary. Okay, now we are going to talk about a new thing called sets. sets are another important Python data structure. Sets kind of work like tuples, but they're not ordered, and they are immutable, so you can change them. You can also say that they kind of work like dictionaries, but they don't have keys. They have an immutable version of a set called a frozen set. So let me show you how you would create a set. So let's do names, and we're going to use curly brackets just like that, and just like that. So we have two names. So you can see the difference is a dictionary, you use the curly brackets, but there's going to be key value pairs. But this doesn't have key value pairs. In a list, it's just going to be a item after item like this, but there's going to be brackets instead of curly braces. So one thing about the sets is that they are not ordered. So sets work well when you think about them as mathematical sets. So for instance, we're going to create a set 1 with Roger and Sid, and we're going to have a set 2, which is just going to have Roger. And so you can intersect two sets. So the intersection of these two sets will be set 1 and set 2. So if I just print that out, print intersect, and then we can just run that, and we can just see what, so it's just Roger. So the intersection of these two sets are just Roger, all the items that they have in common. You can also create a union of two sets. So instead of just calling this union, I'll put mod for modification, and so I can show a few different things with the same variable name. And the union symbol is just the straight line like this. It's not an I, it's just the straight line. It's on the same key as the forward slash backslash, one of the slashes. Now we're going to get every single item in both sets, which happens to be, in this case, just happens to be the same as set 1. But if we change this one to the word Luna, it's just a different name, and now we're going to get each item in both sets, or Sid, Luna, Roger for the intersection. And then we can also get the difference between two sets. So let me change this back to Roger, and for the difference between two sets, I'll use the minus, and the difference is just going to be Sid. That's the only thing that's different between the two sets. You can also check if a set is a superset of another, and if a set is a subset of another. So how you would do that is, so we're just saying, like, is this greater than that, which means it has everything in the other set? True. Now, if we put it the other direction, does this set have everything in this one? No, it doesn't. You can also count items in a set with the length function. That's pretty self-explanatory. I won't even show it to you. We've seen the length function so many times. You can also get a list from the items in a set by passing the set to the list constructor. So I'm just going to remove this, and we will do list set 1. Okay, so now we have a list of the set. And then you can check if an item is contained in a set with the in operator, just like the list and the other places we use the in operator. And then one more final thing about a set. A set cannot have two of the same item. So that's another thing that's useful about sets. So if I type in Roger, so now we have Roger, Sid, Roger. If I play this, we'll see it's only going to print Sid, Roger. It's not going to add the Roger twice to the set. So that's another useful thing about sets, is that make sure there's only one